Okay, so let's get started. Okay, so let's see if there are any questions about the exam or any topic that you want to go over. Huh. Is anybody here? Okay, good. So let me see some faces and some questions. Good. I guess you're in the middle of preparing for finals. So maybe half of them done? No? Maybe not. So, okay, so let me say something about preparing for the finals, right? So we will start off the discussion there. So the first and second midterms are pretty representative, right? So I think if you the problems you're going to see in the final are not going to be radically different from what you have seen before. So in terms of preparing, what you should do is you should look at your the two midterms. I think you can access them on Blackboard now, and also look through all your homeworks, right? So if you understand how to solve all of those problems, right, then you should be fine for the final. So let me just clarify what I mean by if you understand. What I mean is that these problems are meant to get you to understand the underlying topics, right? So as long as you make sure that you understand the topics through those problems, then you should be well set. Okay. Uh, Any other questions? Everybody seems to be very quiet today.
Are there any topics that you're maybe going to test more than others?
No, not really. But as I said, there are many more topics that we covered before the first midterm than after the first midterm, right? So you're going to see, uh, about half the problems are maybe a tiny bit more than half the problems from what was covered before the midterm. Okay. And you are certainly going to see some problems on standard ML of the kind that you are asked to solve in your last assignment. Okay. Uh, and yeah, so in my opinion, right, and in my experience, the best way, the maximum amount of learning happens when you study the material in one shot, because then you make connections between different parts of the different topics that you may not otherwise make if you study one topic in isolation. Okay, so that's why uh, I want to emphasize that you that's why the finalist is going to emphasize all of the topics. Okay, and obviously uh, uh, it is difficult to actually study through all the slides, but that's why you have your homeworks and exams to sort of give you more of a focus on what you need to look through. Any other questions? So any problems that you want to, any topic or problem that you want me to go over, right? Because I'm not trying to detain you here for when you can be doing something else more productive. Wow. Okay. So maybe this will be a very short meeting.
For myself, maybe like propositions and predicates, like some of the questions where it's like, does this mean that there's two elements or more than one?
Yeah. So let's see. Where would we start? I think there is. Uh, okay. So trying to give me a second because I need to find something that you can look at. Okay, so so in terms of topics in logic, right? So you should certainly be able to do the type of problems that you are given in the first midterm, which is, given a proposition, see whether, what it really means, right? So that's the underlying concept, right? So if I said, um, start with something simple, right? So obviously I want you to understand that right? So if you know P implies Q is true, and you're also given P, then of course, if you the uh, the meaning of implication is that, if this is known to be true and the precondition is true, then of course you can you can assert that the postcondition is also true, right? So you also want to be able to understand that, you need to be also familiar with the fact that P implies Q is the same as, not P or Q, right? And you have, De Morgan's laws, right? So for instance, or let's just use the negation symbol, right? Right. So you need to be able to apply these. And of course, depending upon the problem, you need to know which which rules will be applicable at what point. And so by using either these types of simplifications, or by going back and trying to understand what a formula really means, uh, you know, using either of these techniques, you will need to understand whether, say, a given formula is always true, or if two formulas are equivalent, right? So I think uh, the underlying skill that we are testing is basically the same, but the nature of the problem can slightly differ. So that's as far as propositions are concerned. You often want to apply one of these techniques, which is either understand in your mind what some formula means, or how to do some manipulation on these formulas. You rewrite them in some ways to see what they really mean. The other technique, of course, is the brute force technique, which is you write down the truth table, and the truth table will give you can give you a clearer picture of what's going on, but it is very time consuming and is not often the approach that you should follow in the exam, right? So you have a bunch of questions to do, and therefore you need to sort of try to get through the questions without getting taking too much time on any one of them. So so with respect to the predicate logic formulas, right? So you're going to be again, there are two things that I want you to be able to do. One is uh, I want you to understand, right, quantified right? So I want you to do that. And at the same time, I also want to be able to, write them, right? So in terms of understanding the formulas, right? So I suppose people use different strategy for understanding what they mean. When you start out, one approach is to simply write it out in English and then try to, read the English and try to understand exactly what this formula is saying, right? But as you get more experience, then the formula kind of makes sense to you directly, right? And the main issue is you need to be very careful and make sure that you are not making assumptions that are not explicitly there in the formula, right? One of the pitfalls of working with English is that not everything is precisely stated. And therefore, what we end up doing is making a lot of assumptions, even about the things that are not explicitly said. And when you look at a logical formula, you want to avoid that. You just want to look at exactly what it says. And, that's all there is. And so when it comes to problems like, there are exactly two elements and there are at least two elements, the real issue is that, uh, you are not carefully looking at exactly what the formula is saying. Is the formula saying that there are, at least two elements, or is it saying there are, uh, exactly two elements, right? So in order to say that something is exactly two elements, you have to say that the formula has to assert that there are no other elements, right? So it should say, hey, there are two elements, which is easy to say, right? So you can say there exists an X and there exists an Y, and X not equal to Y means there are at least two elements, right? And then you need to say that there does not exist a third element, right? Which means you need to say that every other element, right, other than X and Y, must be equal to either X or Y, right? So you need to make sure that all of these pieces are in there, right? Because to say that something has, say a set has exactly two elements, you need to, you know, there are two sides of that. One is to say it has at least two elements, and the other one that says it doesn't have more than two elements. And if both are captured, then you have a formula that says exactly two elements. So that's what I can say at a high level about these types of problems involving logic. If you have something more specific, a more specific question, go ahead and ask, and I'll try to answer. Okay, so someone wants me to ask the question about pigeonhole principle. So we will try to go over that material quickly because it's not. So one of the things about pigeonhole principle is that it is not saying something probabilistic, right? It's not trying to say there is a high chance of something being true, right? It only tells you what is definitely true. So, so it doesn't quite work like, you know, the kind of arguments that you have when you think about probability or conditional probability, right? So, so the generalized pigeonhole principle says that so if you have a set of size A, which basically means, you have, let's call that, n, right? The size of A could be n. And if you are trying to fit, you know, n elements, if you're trying to map n elements to m elements, right? And, n is greater than k times m, that means that each element in the set n has to be mapped to at least k elements on the right? So that's or rather k plus one. That must be okay. So I misspoke, which is, it's an important point. So let me just go back and correct myself. So what the principle says is that if n is greater than or equal to, if n is greater than k times m, then any function, any total function, right? So because it should map every element in A, any total function that maps from A to B should map at least k plus one different elements to an element of B, right? Remember, it doesn't say that every element must be mapped to at least k elements, right? Because it's certainly possible that you can map, n minus, so you can map n minus one elements to one element, right? And you can map, one element to the second element, right? So, or worse, you can take all n elements and map them to one element in B, right? So it doesn't say anything about, how many elements within B are mapped to, right? It just says that there exists at least one, which must have, k plus one. And that's kind of where people tend to make mistakes, because they tend to think, okay, it says something about, uh, every element over here in B. It doesn't do that. It just tells you that there exists at least one element in B, which has a certain minimum number of arrows coming in. Okay. And we use that to look at several problems, like how many people have the same number of hairs on their heads, right? Things that seem very unlikely, but become true because you are considering sets that are very large in size, right? So if the number of hairs is going to be drawn from a smaller set than the number of people, then of course you should have several people that have the exact same number of hairs. Any other questions?
Could you go over, it was one of the practice midterms, it was question 7. I can send the
Okay,
link
so,
down.
Okay. Okay, so I'm going to So can you say that again? I'm sorry, I got distracted.
It was the first midterm, the practice midterm,
Yeah.
and then question 7.
Okay. So let me pull that up here and then. I will- So this is something that you have, the specific problem is something that you haven't looked at, right? It is, if you remember your, you know, some of the math that some of you may have taken in your high school, then you might recognize this as uh, the series for defining, I believe this is E, right? Let's see. So let's just try to work out this problem, and then maybe instead of telling you that you haven't seen it, it's definitely something that we can. Um, Give me a minute. My iPad is unhappy. Okay, so so the series that's given is right. So if you simplify, then it becomes so I guess. Right? So once you do that, then it's clear, what happens, right? So things, everything is going to get canceled out, right? So So why am I stuck? The reason why I'm stuck is that you can't really cancel out like this, because there is always the last term, and the numerator of the last term becomes larger and larger, and no matter where you stop, right, you cannot just omit the last numerator, because that numerator gets larger and larger, right? So although we can simplify like this is not going to lead you to a result. This is some familiar series which I'm not able to recall immediately. It might very well be the expansion for E. Okay, so the point is that if you didn't know that, then you would not be able to you may not be able to solve the problem. Okay, so if somebody has a different idea, let me know. Otherwise, I see this as something that you're not familiar with, so you wouldn't be able to do. N plus 1 divided by 2, well, of course, but that doesn't have a, this is an infinite series, right? So essentially that would mean it's infinity, right? Which it very well could be, but it is not a proof, because you cannot stop at n, right? It's an infinite. No, it's only 1 by n. I'm so sorry. Okay, so then we are done. Sorry, I did not realize that that's what it is. Okay, so for some reason I saw this as an infinite series, but it's not an infinite series. It's a finite series, in which case whatever simple calculation that we did is is going to be okay. And there is in fact a last term, which is n plus 1, and so this will be n plus 1 by 2. And then to prove it by induction is very straightforward, right? It's like a almost a trivial problem. So the usefulness of that exercise is more in terms of you walking through the steps and making sure that you are able to write these induction proofs than proving anything in particular, right? Because what you will end up with is if you do this, then this product by induction hypothesis will be n by 2, right? And then if you multiply this by this, then you'll have n by 2 multiplied by 1 plus 1 by n, which is right. So it's, the proof is very simple. All you need to do, the main thing that's being tested in the induction proof part of this problem is whether you can write out an induction proof with a certain structure. Okay, so homework question 3 from homework 6. Okay, homework 6. So so this is problem 3 from the last homework, right? So there are 3 algorithms that are given, and you're asked to pick which one is better based on which will run fastest, right? So you have algorithm A, and you can write the recurrence for algorithm A from the problem statement. And so since you saw the solution, maybe you can ask what it is that you would like me to go over in this problem. Because just going over, Michelle, is it about how to conclude from the answer, or is it not clear how the recurrence leads to a particular solution? About the recurrence time. Which one is faster, right? Okay, so that makes sense, right? So so in general, right, a power n, right, for any a, right, this is exponential, right? And it always grows faster than right? So exponential algorithms always grow faster than polynomial algorithms, right? So this is like a polynomial, right? N to the power k is, so then you have, that this one is going to be the exponential algorithm, which is taking 2 to the power n, is going to be slower than the other two, right? And now you are left with 2 choices: n square log n and n to the power log 2 to 5, which is, we can say right? So log of 5 to the base 2 is something more than 2, right? Because log 2 to 4 is 2, right? And log 2 to 8 is 3, right? So 5 is something a little bit larger than 2, right? And now if you compare this, right, and say divide one by the other, then you can say that n square log n divided by n to the power log 2 to 5 is less than n square log n by n to the power 2.1. And then if you and once again, the second thing that if you flip it around in terms of not talking about exponential versus polynomial, but in terms of logarithm versus polynomial, then you will see that log n to the power k grows slower than n to the power L for any integers k and L, right? So log is always growing slower than a polynomial, okay? And therefore, okay, so I should say L, was not careful here. And for any integer, I should not talk about integers. Let's just say right? So for any k and L greater than 0, right? It need not be integers. It can be any fractional numbers. So logarithmic functions always grow slower than any power of n. And so then that allows you to compare these two. And then you can say, hey, so n squared log n is the one that grows the slowest. Next.
Could you go over the concepts of CNF and DNF from
Yeah.
like from
That's
that
fine.
first unit?
So CNF, let's just give some examples, right? So right, so that is a conjunctive normal form, right? So you have the outermost symbol is always an and the inner symbols are either variables or negations, and then they are all connected by disjunction, right? So this is CNF. In a DNF, you flip the roles of conjunction and disjunction, right? So right, so this is DNF. So now I don't know whether I answered your question, but so if I didn't, then
I think I just had like wanted some clarification on like, are these just like
sorry, you're breaking up.
like for anything? I kind of guess I was wondering like what kind of question.
Okay, so what kind of questions may be there? The questions may be, you are given a formula and asked to convert it into a CNF, right?
Okay, yeah, that makes sense.
Okay, so and we don't study any kind of systematic algorithm for doing it, but In the same way, we don't study its systematic algorithm for checking whether two formulas mean the same thing, right? So it's not going to be, if you're asked to do solve that kind of a problem, you aren't going to be given a horrendously complicated formula and then asked to do something. Okay. Most of the time, when you have to convert it into a normal form, it typically involves, applying distributive laws, right? So you have, uh, what is this? Right. So now this is not in, disjunctive normal form, but this is in DNF, right? So that's a simple example. Okay, so you're just applying a distributive law so that, you get your preferred operator at the top level. Okay, by applying distributive law this way, you can generally convert any formula into either CNF or DNF. So again, make sure that you understand, sets and set operations and properties of sets. And again, what relations are, what is the relational composition, what does it mean for your relation to be injective, surjective, all of those concepts that we went through in the exams and the homeworks, make sure that you understand them and you understand what, how to count sizes of infinite sets. What is the meaning of closures, symmetric relation, transitive relations, closures on given relations, applying symmetric closure and transitive closure. What are graphs of relations? What is a path in a graph? What is a walk in a graph? What are cycles in graphs? What are different types of cycles? So make sure that you're familiar with all of those, so you'll be able to answer problems if they arise in the final.
Could we go over some counting problems, like the like people sitting at a table problems?
Okay. There are many people sitting at the table problems. Maybe you're talking about, okay, no, maybe not. Maybe it's all about this, there's a circular table type of thing. Is that okay. So the way you do those problems is you count the number of arrangements if they are in a row, right? And then if they are in a circle, then you divide by 2 times the number of seats on the table, right? So if n is number of seats, right, then you divide by 2n, right? Why? The 2 says, you can arrange, take each clockwise arrangement of guests and, make them anti-clockwise, right? And that's not going to look any different in those types of problems, because the who is sitting next to who is not going to change if you take people that are sitting clockwise around a table and just make them sit anti-clockwise, right? So that's where you get the factor of 2. And this is, rotate people one position over. Right? So for each clockwise arrangement, there is an anti-clockwise arrangement. And for each position, if you simply make people rotate by one position, then it's the same arrangement in terms of who sits next to who. So you will take essentially, let's say if there are so if you have m guests, right, of which you are picking n, right? So if you just stand them on a row, then you have m factorial by m minus n factorial arrangements, right? Because it's just permutations. If you make them stand on a row, then it's just all possible permutations of n people chosen from m people, right? And that formula is this. And then we are going to apply this division rule, which is over here, and we are going to just divide it by 2n, right? And there isn't a whole lot of variety to this problem at this point. And for that reason, I'm not going to ask you that problem in the exam.
Okay. I just remember there was a question from, I think, like the practice midterm,
Yeah.
where it was like students around a table, and I got confused because
So do you remember which one it is?
not off the top of my head.
Okay. Because are you sure? Because the practice midterms I gave you didn't cover counting.
It might have been a homework. I can
Yeah.
email you about it and like find.
Yeah. There is, definitely one homework in which homework 4. Okay, so let's. And it wasn't a problem that you were asked to submit, right? So problems like this will have variations where additional conditions are introduced, right? So, 2 people have to always sit next to each other, right? Then what you do is you just remove one of the seats, right? Because they have to always be together. So you might as well just fuse their seats into one. So then you say, okay, there are only n minus 1 seats. And then, calculate all possible arrangements. And now you bring these 2 people back in. And, you can now put them in 2 different orders. And so, because you can, depending upon the order in which they sit. So now what you will find is so for instance, there's a problem here that says, 2 people have to sit together. The original so you originally have 8 people So 8 students on 8 seats, right? And if there are no constraints, then you have 8 factorial divided by, you know, 2 times 8, right? Because we said you should divide by 2n, right? So 8 factorial is the number of possible permutations of 8 students, and you divide by 2n, that gives you if there are no constraints. Once there are constraints, let's say 2 people have to sit then the number of seats becomes 7. So you first do this 7 factorial by 2 times 7, right? And you know, now you can and now, you know, there is going to be twice this because this few seat, now you split them and you can, you know, arrange, you know, either if the 2 students are A and B, you can either put them AB or BA. And each of these will, you know, change who they are sitting next to. And therefore, you basically have to multiply this basic thing by 2, right? So the variations are handled in a you know, somewhat similar way, right? So we have seen other problems where you know, it's another problem involving numbers where 2 digits you know, have to always occur together, or repeating digits have to occur together, or something like that. So this idea of just removing one position to account for the 2 things that have to occur together is a general technique that you use for all of those problems. So we are probably going to use the lockdown browser for the final. Okay, we are probably not going to do the second midterm style. Okay, there are going to be more problems where you select from available choices, and that is better done using you know, lockdown browser. Anything else? So I will post another article, or at least one article between now and does anybody, we might set up a practice lockdown browser session anyway, even if you don't want to do it, or if you want to do it, either way, it'll be there. But do make sure this is the final, right? So when I tell you here are the things to avoid during the final, pay attention to that, right? Because obviously the integrity of the exam is very important, even more than the other exams we have had. And we certainly, you don't want to put me in a difficult position, and I don't want to put you in a difficult position. And the easiest way to avoid difficulties is to look through the instructions that we post for how to conduct yourself during the exam, right? Like making sure that your audio is always on, and your face and at least the upper part of your arms are visible to us, right? So we can roughly see what you are up to during the exam, right? And then make sure that your phone and other things are far away, that you're most importantly, you are not wearing headphones, right? So these are all very important. So make sure that you follow the directions as posted, okay? Otherwise, we don't want anyone to run into trouble. So the finals are always 2.5 hours, right? So that's the slot. I would suggest that you be there a few minutes early. So I will, once again, when I have finished making the finals, then I'll be able to post more detailed instructions on exactly, how, what the arrangement is going to be. Okay. So yeah, try to be available a little bit ahead of time so that in case you run into any difficulties, well, we can resolve that. Okay. Any other questions?
Professor, like when we draw probability trees,
Yeah.
do we like base the probability tree like what the question is asking and only like include those scenarios, or do we include like all scenarios?
I'm sorry. You're asking whether is this related to the lockdown browser?
Oh no, sorry, it's like a question on probability.
Yeah. So what about trees? Because that's often the type of problem we solve, right? So we draw trees to think about conditional probabilities. So can you say it again, maybe because I didn't catch your question the first time.
Okay, yeah. So like if the question is asking about like a certain probability for the tree, do we draw like the branches that relate to that probability and we like exclude all other scenarios that aren't related?
Yeah, of course, because you want to make sure that you that the tree can be drawn in a quickly, right? Because there are going to be some cases where the tree is very large. Like for instance, in the second midterm, if you drew the entire tree, then it would take a long time and it would be a lot of calculation. What you needed to say is that, okay, there is this, I think you're already told in the question, not to worry about, where the prize is or something like that, what door the prize is behind, right? Because the structure of the tree below that level is identical no matter which, where the initial choice is. So you need to think along those lines and say, yeah, these things don't matter. The rest of the tree is going to look exactly the same. So I can analyze this subtree and then, scale that result to all other subtrees or apply that result to all other subtrees.
Okay, thank you.
Okay. Okay.
There's 2 questions in the chat.
I already answered the how long the exam will be. And so if you do lockdown browser, right, then there won't be anything that you will upload, scan and upload, right? So if that, this is why I don't know for sure whether we are going to use a lockdown browser. It certainly looks more like it, but when I finish setting the exam, then I will know for sure, right? Because I need to then either stick to questions that don't require scanning and uploading, because scanning and uploading while using the lockdown browser is a little bit more difficult. So so then I'll have to make problems where you don't have to do you don't have to write a whole lot of math, right? Whole lot of formulas, right? Something that you can express by simply typing. That's what I will have to stick with, right? Of course, you will have your sheets of paper to work on, right? Because the problems themselves are not going to be so different depending upon which method you're going to enter the answer, right? So so you will have sheets of paper on which you will be working out and then entering your answer on the browser. Okay. And yeah, so if we use the lockdown browser, then there will be nothing to upload. Anything else? Okay, so if you have any more questions, you can always post them. And the earlier you post those questions, the more of a chance you give us to answer. If you post them, Tuesday morning, then maybe the answers are not going to come in time. Okay, very good. So good luck with the final. Again, the questions should be somewhat familiar, and as long as you have all the basic concepts, if you have understood, then you should do well in the final. Okay, so don't need to worry. It's going to be, as I said, 2.5 hours. So it's not something that I expect people to finish in 1 hour and walk out, right? So you will. Yeah. So the question should be familiar. The exam may have 15 to 20 questions depending upon the size of the questions, right? So obviously, for both midterms, you had about 10 questions each. So that's kind of scaled up to the length of the finals is sort of what you can expect in the finals. Okay, so good luck, and I'll see you at the finals. Okay, very good. Thank you.